This is my video showcase covering my creative output, the level comprehension of embedded narrative. This project aimed to develop a playable experience with an embedded narrative and then evaluate how players understood it through the use of comprehension data and gameplay telemetry. The methods used to embed narrative within the levels was through the use of NPC scripted vignettes, player and world mechanics, and environmental storytelling. Analysis was then conducted through the use of a multiple choice style comprehension questionnaire, using the core related testable areas, locate and recall, integrate and interpret, analyze and evaluate. Additionally, to support the analysis process, telemetry data was also collected during players' playtime. This included watched NPC scripted event, player location related data, and interaction data. This collected data can then be visualized easily through tunable systems for analysis. The game can be played immediately from the playable level through hitting play. However, this doesn't automatically enable the telemetry collecting system. To do that, you first need to launch into the telemetry setup level, inputting a name, updating the run ID if needed, before hitting start, which enables the save game data and allows for telemetry data to be recorded. Alternatively, running the build automatically opens into the telemetry setup level, allowing telemetry data to be collected immediately. For the introduction, a tutorial is given using the screens that act as cameras to view the player, introducing them to mechanics of them being watched, along with their ability to preview when watching will occur. This also introduces the player's ability to crouch, jump, and lean before introducing them to the rest of the map. After exiting the room, they're introduced to one of the first NPC scripted vignettes. This is where they drag someone back, and then also after bumping into them twice, they then point at you and kill you. This is also where the goal point is introduced, kind of after walking out through there, where then you're open to travel wherever you want to get to that goal location. This is also where one of the alternative routes into the building is also outlined. And then down below is another scripted event that the player can view, which is then also collected and tracked within the telemetry data. This section here, the player is approaching a stealth area, so all AI within the level have a sight cone and a hearing cone. That hearing cone can be triggered by thrown objects, as well as call-outs from the camera screens. So in a minute here, the red bar will fill up, switching to the viewing mode, where the player will then be seen alerting guards in the nearby area, which is why the guard in front of them turns around. And this route is one of the two main routes into the upper area to continue forward to the main goal. Here is another of the scripted events the players just watched, which are triggered by the player being in vicinity and also looking at their trigger point. Outside of scripted events, there are also reactionary events. So here, for example, the orange guard salutes to the guarding glasses. And here we'll speed through to the next set of environmental storytelling, which illustrate the government's use of blocking on windows to restrict visibility, allowing players to see it plainly rather than just on regular buildings where it might be missed. And now moving through to this room is where the use of the camera watches are. So here the player is waiting until they're no longer being watched to move around and get through the rest of the building. This section here now unites with a main path. So previously to this, there were two different routes the player could take to get to this floor. And from here, I'll play the video section from the other direction in. So this alternative route enters through the main door, where the player needs to move around to then gain access to a lift that is currently being guarded by dropping down below. Within the level, death of the player is currently handled through a respawn, where they then respawn into an area that is safe and they're not violating, allowing the player to re-enter safely without enemies re-aggroing immediately. The enemies also, upon finishing dealing with the player, return to their spline point position on their patrol, so that there shouldn't be any sequence breaks that mean that a player physically cannot get past or through an area because of overlapping AI. This section here also shows through environmental storytelling of the homeless population being locked up and imprisoned as the way the system handles them. Speeding through this next section, the player needs to work their way around to the corner on the opposite end from where they started, where they climb up onto a ventilation duct and move across around the room to then drop into the lift, using the green button that upon activation becomes red, showing its inactivity for the player to reach the next floor, resyncing with the main path that the player could have taken the alternative route to get to. This area funnels the player into this room with the goal of reactivating the lift through pressing the green button on the upper walkway. In this section, gameplay functions similar to before, with patrolling and stationary AI that force the player to take particular routes to move around the area without being caught, and reach the final goal of the top floor, where a player can make a decision to just play a video or to kill the enemy standing at the top before pressing. After pressing the button, a sequence starts where a camera moves around the level, while a video, which would have been previously unimaginable to most of the society, living under a totalitarian regime, is shown playing across the world, signifying the newly accessible information to the people. I'll now move on to the visualization process of taking the telemetry data and inputting it into the engine. To begin with, the data needs to be taken from the saved section of the project inside the created telemetry folder. It then needs to be opened in Excel as a CSV data and transformed to change one of the variables to be a decimal rather than number. After this has been completed, a new column needs to be added into the first row, having a unique number for each different row. This is to allow for the Unreal Engine data type component to correctly read and take from this dataset. Once the data has been prepped, it can then be imported into the engine, going into BP's telemetry system, visualization, and then accessing the telemetry visualization data, where the reference to the data can be changed and re-imported to have access to the new dataset. This data can be changed and swapped out easily, while still enabling the visualization processes to function correctly. To utilize the collected telemetry data, a user must open the level where the data was collected. Within the outliner, select the telemetry visualizer, and select between a list of enums for different visualization methods. Currently, the path view is active, where you can see the path the player took during play, moving through hue colors to allow high traffic areas to maintain clarity of which path relates to itself within chronological relativity. Alongside this path view, a user can also use the weighted view, which utilizes player traffic in particular areas to increase color intensity and opacity strength, allowing for areas of high traffic to be clearly visualized. This visualization is also tunable through the use of the grid size slider that enables larger areas to be considered within an overlapping area. Each weighted object also has an exposed variable showing the weight of it, allowing easily viewable data of how many instances a player was in that particular location. This system is easily tunable, with multiple different variables being used and looked at. The path and weighted path visualization methods are also utilizable with look positions. Finally, I'll go over some blueprints and mechanics in order to highlight their importance and implementations. To begin with, I'll focus on my AI, involving 3 different components that link together: the base AI, the AI controller, and the AI behavior tree along with its blackboard. These 3 components work in tandem to create a reactive AI that responds to player actions and behaviors while maintaining optimized behaviors within a large complex level. To begin, I'll cover default behavior of AI patrolling. This functionality lives inside the default AI character. It takes an editor selected spline, moving through its spline index values to provide location data for the AI to move and travel between. Moving on to another section within the default AI character, optimization system, enabling the pause of movement and AI perception updates, improving the performance of all AIs. Having a section triggered and controlled through player overlap allows for a reduction in the amount of perception checks being carried out at one time. This optimization enables the active AI to perform their perception update checks more regularly, as they're not being limited to a large number of checks happening at the same time if all AI were active. Finally, under the same umbrella of AI is the perception and alert-based systems. These systems allow AI to react to player behavior and locations within levels, responding and acting in different ways depending on the alert level active within the AI, deciding and updating the different behavior tree states the AI picks between. Now I'll move to the lean mechanic based in the first-person character blueprint. To allow for correctly updated collision, calculating areas where the player physically should and should not be able to lean into, stopping clipping and other issues. This mechanic functions similarly to the Dishonored series and allows for the stealth gameplay to function, viewing around corners and above obstacles. A set of line traces that utilize time-based hitting methods to set the bounding areas the player can lean into, rather than relying on collision-based methods. This mechanic, like the others on the player, also supports controller inputs. I now shift focus to the telescreen and telescreen manager. These are the screens in the level that view and watch the player at incremental times using a warm-up and cooldown period. The manager controls the affected screens, linking them through the editor. This manager randomly tests the linked screens, starting them if available, as well as enabling and disabling the preview mode the player can activate. Within each screen there is a timer that increases their progress bar, which signifies the start of when the watching person will activate, and upon seeing the player will report them to AIs in the area. Finally, I'll cover the scripted AIs and conductor blueprints. These blueprints use instance editable arrays and maps for the scripted AI bases. This then allows for actions such as playing animations, looping animations, changing meshes, killing the AI, ragdolling the AI, moving and rotating. Within the conductor scripts, there is an activation setup of a player being within range and looking at a trigger. This then begins an event that flows chronologically using delays and set AIs to perform actions relative to one another, creating mini-stories in the world furthering the embedded narrative of the level and wider world. This concludes the showcase of my creative piece. The final build demonstrates a playable, embedded narrative experience supported by NPC events, environmental cues, mechanics, and telemetry systems. The next stage of the project is to complete the analysis of the collected player data and evaluate how effective the experience supports narrative comprehension.